Good afternoon, everybody. Now we are going to discuss what is a binary decoder. This experiment is to realize and implement a decoder circuit. So you need to realize and implement this function using a decoder, that is decoder IC 74138. Before getting into that, we shall understand what is decoder. The name decoder means to translate or decode coded information from one format to another. So, a binary decoder transforms n binary input signals to an equivalent code using 2 to the power of n outputs. Got it? What do you mean? What is this? If two inputs are there, you will be getting 4 outputs. If 3 inputs are there, you will be getting 8 outputs. So, how is that possible? Let us see an example. Okay, see here, when I have one input, that is A, so that I can take it as two outputs by inserting an inverter. So if I take the output through inverter, it will be A bar, and if I take the output directly, it is A, right? Similarly, if I have two inputs, then I can take the output in this fashion. See here, A, B, two inputs. From A, I can have two outputs, that is through inverter one output and directly another output. Next, from B, one output directly and another output from inverter, right? So that in that fashion, we know that if we have two, we can have 4 different combinations. So the same we can get here. See, just observe here. It's very simple. It's very simple. For this circuit, if I write the truth table, it will be like this. A, B, I have two options. If I apply 0, 0, I'll be getting output at Q0. If I apply 0, 1, I'll be getting output at Q1. If I apply 1, 0, I'll be getting output at Q2. And similarly, if I apply 1, 1 to input A and B, I'll be getting output at Q3. And this is the symbol to represent a 2 to 4 binary decoder. 2 inputs, 4 outputs. Similarly, if we construct a 3 to 8 decoder, the same fashion we can develop 3 to 8 decoder, 3 inputs A, B, C, and obviously you'll be getting 8 different outputs, right? So for different options of A, B, and C, I'll be getting output at D0 till D7. So one more pin is there, that is enable pin, and the IC. Yeah, this is nothing but the 3:8 IC 74138, right? So it is 74LS138 binary decoder. Okay. So let us see the IC pin details also, how it is. So this is the decoder IC 74138. Here we will be having 3 inputs, that is A, B, C, and the 8 outputs. Why not 2? Y6 here, one more output is here, Y7, right? One more output is here, VCC ground as usual, and these are all enable pins. Okay. So coming to the decoder, a binary decoder is a combinational logic circuit that converts binary information from n coded inputs to a maximum of 2 to the power of n unique outputs. converts binary information from n input lines to a maximum of 2 to the power of n unique output lines. If the n bit coded information has unused combinations, the decoder may have fewer than 2 to the power of n outputs. The decoder is called n to m line decoder, where m is less than or equal to 2 to the power of n. I mean, see, if I don't need all the 8 outputs, then I can limit only few outputs like that. Okay, so if I can use this 3 to 8 decoder as 2 to 4 decoder also, right? If I don't give any input to C input, then obviously I'll be getting output only in the 4 different outputs, that like that. Got it? So I can use this to make use of this 3 to 8 line decoder for a particular function. Okay, for a particular function. So here, so first coming to the analysis, the given function is f1 is equal to x bar y z bar plus xz. So okay, so that I cannot use it as it is. I need to expand it. Okay, I need to expand it. F1 is equal to x1, sorry, x bar y z bar plus xz into y plus y bar. And if I expand it, I will be getting like this. So for F1, it is sigma of 275, right? So x bar y z bar means 0, 1, 0. So 0, 1, 0 is this. Okay, okay. So so this is actually F1 bar, okay, because active low output. So this IC is active low output. That is why we have taken it as like this. 0, 1, 0 is 0, and next one is 1, 1, 1. XYZ is 1, 1, 1. That is also 0. Next XY bar Z, that is 1, 0, 1. 1, 0, 1 is 0. So for these three values, for these three different inputs, you should get output high. For any other combination, you are not supposed to get output high, or you are not supposed to get the output. So this is what we need. Similarly, F2, x y bar z bar plus x bar y. Okay, that we are going to expand by including the missed variable. Okay, missed variable means here z is missing. How can we include z? I cannot include z, right? I can include it as 1. 1 is nothing but z plus z bar. So if you expand, you will be getting 4, 3, 2. That is x y bar z bar plus x bar y z plus x bar y z bar. Okay, that is 4, 3, 2 for these three options. So here you can see 2, 3, 4. So these three options we are giving active low because a output is active low, right? So that is why. So next F3 is x bar y bar z plus xy. Okay, here once again z is missing. If I include, I will be getting 0, 7, 6. Okay, so 0, 7, 6. Like this, we need to construct the truth table. Now, what is the task? I need to rig up the circuit. So from 7413, the decoder circuit, such that only for these three min terms or these three terms, F1 should give the output. Okay, so coming to F2, 2, 3, 4, only these three different inputs should give the output. Coming to F3, 0, 6, 7 should give the output. For any other input, different input values, F3 should not give the output. So that is what the circuit. So how to do that? So particularly when come to F1, you have 2, 2, 5 and 7, right? 2, 5 and 7, you combine it and connect it to AND gate. Connect it to AND gate. So when will the AND gate will be high? When all when all these three outputs are high, only then AND gate will give high output, right? So that is what we are going to do. See here. So this is for F1. You can observe this is connected to Y2. Okay. Just a second. So Y2 is connected to F1. Next 5, which is 5. This is 5. This is connected to F2, sorry, F1, and finally 7 is connected here to this gate because the output of this gate is given to this gate. Okay, so now what happens? For these 3 different values, you will be getting output high. Okay, you will be getting output high. For any other input combination, you will not be getting the output. Okay. So this is a decoder. You are going to repeat the same. You are going to rig up the circuit for all 3 different F1, F2, F3, and you are going to try the output. Similarly, continue and solve for the second function given. In the second function, we have y bar plus x into z. So expand it, include the missed variable, and convert it to min terms. Similarly, F2, include the missed variables, convert it to min terms. Also F3. So if I do so, F1 is equal to sum of 5, 1, 7, and F2 is equal to sum of 4, 0, 3, 2, 6. Finally, F3 is equal to sigma of 7, 5, 3. So now what am I going to do? I am going to combine 5, 1, 7 outputs to an AND gate. Okay, and I am going to get the output as F1. Similarly, 4, 0, 3, 2, 6. I am going to combine through AND gates, and finally I am going to get the output for F2, similarly F3. So your circuit diagram will be like this. You can observe here for F1 you have, so this is F1, you have connected these values, that is 1, 5, 7. Okay, so these 3 values you have connected to F1. Here we are not going to use a 3 input AND gate because it is not available in our lab. So connecting through 2 input AND gates means we need 2 AND gates to connect 3 different values. So that is what we have done. Similarly, coming to F2, we have connected 5 different inputs through AND gates and we are getting the output. And finally, F3. You can either connect all the functions together and try getting the output, or else you can try try getting the output for individual function. Okay, it will be better if you get the output for all the 3 different functions at a time, but it is little bit complicated because more number of gates are there and it will be little bit difficult to debug the error. So better you get the output for each and every function individually. Let us connect this circuit using this circuit on the digital trainer kit, and let us check the output.
This is the circuit of decoder. So this decoder is also called the 3:8 decoder because we are having 3 inputs ABC and 8 output. So hence it is also called as 3:8 decoder. So inputs, the pin number of this input is ABC, IC 1, 2, 3. This is according to the pin configuration. Anyhow, you will get the pin configuration. We have to look into this pin configuration, accordingly write the pin numbers. So I have also did the same thing, looking into the pin configuration of this one pin diagram, have written the pin numbers of the corresponding output and then input. So 4 and 5 are the ground, so I connected 4 and 5. These are the enable. 6 is the enable, 6 is connected to enable, that is I have to make 1. VCC 16 is VCC, 8 is ground, and these are the 8 outputs pin numbers, so I have written. So and then for this, in order to implement the function F1, so we are using 2 AND gates, and for AND gate IC number is 7408, and in one IC 7408 we are having 4 AND gates. So for this experiment, to implement F1, we have to use one IC 74138 for this 3:2 decoder and one 7408 AND gate. Okay, so this is 74138. So first I'm using the second slot. So place the IC properly, so without leaving the first slot. So then I'm locking this IC. So then immediately as soon as we connected the IC, we need to, first thing what we have to do is we have to connect its ground and VCC. So pin number 16 should be the VCC. So this is the VCC R1. So and then pin number 8 is ground. Here this is 16 pin IC, so there is no vacant slot in, there is no vacant slot. In the beginning experiments we are using 14 pin IC, so that's why we are getting last 2 are vacant, but here it is 16 pin, so it fits completely, no slots are free. So next, so connect now A, B, C are the inputs. A pin number 1, so I'm taking this is A, this as B, this as C. Input A is connected to the pin number 1, input B is connected to the pin number 2, and input C is connected to the pin number 3. Okay, so A, B, C, 1, 2, 3, that we have did. So input side we did, and then 4 and 5 both are ground, so I am making these two common. So from take a okay, 4 to 5 you connect this, and then from to any one of this you connect to the ground. So I'm connected to the ground. Okay, this part is over. Next, pin number 6 is enabled. That means we have to make it as 1. So pin number 6 I'm connecting to VCC. This is over. Again, pin number 16 is already did, and 8 is already did. Now we need to connect the outputs. Now here, which are the outputs we have to use? We have to use only the outputs. The pin number 13, that is D2, and pin number 10, that is D5, and the pin number 7, that is D7, because we need to get only 2s and 5. If any one of this min term is 1, then only output should be 1. So that's why if I give a 0, actually this is 3 input combination. If you give 3 input, 8 combination will get. Out of 8 combination, if you get only 2 means 0, 1, 0, and then 7 means 1, 1, 1, 5 means 1, 0, 1. If you give any one of these 3 outputs, then only output is 1. If other than this, if you get 0 or 3 or 4 or 6, for this input, for this combination you get output 0. So I'm using only these combinations. So pin number 13 to pin number 1 of AND gate. So AND gate I see I'm using in the third slot. See, now this is 14 pin IC, so last 2 slots are vacant. Okay, so for this one I am using ground. 14 pin number 14 is ground VCC, and pin number 7 is the ground. So then we are connecting pin number 13, the pin number 13 of 74138 to the pin number 1 of this AND gate IC. So 13 of this 74138 to 1 of this AND gate IC. So next, pin number 10 of decoder, that is 10 of this decoder to pin number 2 of AND gate. So that is also done. Then output of this we have to connect to the input of another AND gates. So that is pin number 3 to pin number 4. Pin number 3 to pin number 4. So then from the pin number 7 we need to connect to pin number 5. 7 of decoder to 5 of this AND gate. See, 7 of this decoder to 5 of this AND gate. So this also completed. Now output we have to see at the pin number 6 of AND gate. Pin number C. So out of this, any one of the output you can select. So I am selecting randomly this one I am selecting. So now after connecting the circuit, then I am switching this on. So now the trainer, the power supply to the trainer kit, now it is on. See, now actually for 0, 0, 0 you should get 0. But for the 0, 0, 0 we are getting 1, ulta. So let me check for the another one. This is for 0, 1, 1. Actually for 0, 1, 1, for 3, the term is not there here. 3 is not there. For that 3 we should get 0. So let me take 0, 1, 1. For this also I am getting 1. Okay, this also. So let 4 is not there. That is for 4 means 1000. Let me check for 100. So 100. That is also 1. That means for that also I should get 0. But I'm getting, again for that 100 I'm getting 1. Let me check for the last one. 110. Actually you should get 0. If I get 110, again this is out. That means for all these things I'm getting ulta. So but actually which are the numbers are there in this given expression? The 275. Okay, for 275 I should get 1, but actually we'll get 0. Let me see. So 0 1 0 2. See, 2 0 I getting. That means 0 1 0 0 1 0. Instead of 1 I am getting 0 here. So similarly for 101 101, actually we should get 1, but here I am getting 0. Okay, so again from 111, actually we should get 1, but you are getting 0. Why? Because this decoder is an active low output. So here outputs are active low. Active low means ulta, that is a negative logic. Okay, so hence since whatever you are getting 0, you are getting 1. Wherever you are getting 1, there we are getting zeros. Because this is because active low outputs. That means say ulta, okay, negation of that one. Okay, so hence this equation is not F1, this is an F1 dash. Again, this is not F2, F2 dash. Again, it's not F3, this is F3 dash. That means for whichever the numbers given in we got in the expression, for those minterms we have to get 0, and whichever it is missing, for that we are getting 1. Okay, for 275 we are getting 0, and for remaining 0 1 3 4 6, for that we are getting 1. Okay, so this is what. Similarly for F2, for that means F2 dash, when you implement F2 similarly, for 2 3 4 you should get 0, for remaining 0 1 4 0 1 5 6 7, for that you have to get 1. Similarly for F3 dash, you have to get 0 for 0 6 7, and for remaining, that is 1 2 3 4 5, you have to get 1. This is what. So how you implemented similarly, you have to implement. So let us for 2 3 4. Let us take another one also. So this is your decoder. Okay, so D0, D1, D2, D3, D4, D5, D6, D7. So 8 outputs. I'm writing only the output side. So this is for 2 3 4. So 2 3 4 means from 2 from 3 you put one AND gate, because it is actually only one AND gate is enough, but we are using 2 input AND gates, so using 3. So 2 3 and then 4. So this one, and then you have another one more AND gate. So this is your F2, not F2, it is F2 dash. Okay, so this is now what are the pin number? 1 2 3 4 5 6. Okay, so D2 D3 D4 pin number is 13 12 11. This is 13, this is 12, this is 11. Okay, so similarly now for this F2 dash you have to get that one. Okay, so everything is same. Earlier we connected that to this one. So just everything is same. So except, see, I have taken only the inputs of AND. This is the AND gate 74. This is 7413. This is the AND gates. Have taken all the inputs from this one. So now I am taken from pin number 13. From pin number 13 to pin number 1. I've connected, and from pin number 12, from pin number 12 to pin number 2, and then pin number 3 to pin number 4, pin number 3 to pin number 4, and then from pin number 11 of decoder to pin number 5 of AND gate. Okay, so then finally you have to take output from pin number 6. From pin number 6, so again I am selecting any one. So now I will again switch on the power. Now so you have seen the output combinations. So this is a circuit connection for this combination 2 3 4. See, for this 2 3 4, see, for 2 3 4 I should get 0 2 0 0 1 0 3 0 1 1 3 0 4 1 0 0 for 0. For remaining 0 1 5 6 7 you get 1. See 0 0 0 0 you are getting 1. 1 for 1 you are getting 1. For 5 you are getting 1. For 6 you are getting 1. 7 you are getting. So hence it is an active low outputs. Active low outputs. And here we use the AND gates. Here AND gates. Okay. Actually, we have to use OR gates, but if we use OR gates, we won't get the output properly always. So that's why we go for the AND gates. So if you use AND gates, it will act as an active low. Hence, we have written F1 dash, F2 dash. Similarly, you have to do for F3 dash. So F3 dash for 0, 7, 6, the output you should get 0, and remaining number 1, 2, 3, 4, 5, you have to get output as 1. Okay, so this is the binary decoder or 3:8 decoder, how it works. Okay, in the exam you may get like these three functions, not the same, exactly not the same. So you'll get some questions. So you have to, whichever the missing term, using that you have to get the expression in this format, and then that is not an F1 F2 F3, that is a dash. Okay, that is active low. So accordingly for those numbers you have to get 0, remaining for numbers you are getting 1. So implement one at a time, and realize. I hope it is understood.